Welcome to this video. My name is Rajvir, founder of Code and Compile, and in this video, I'm going to show you how we can integrate OpenPLC code with Python. What you're looking right now is a PLC sending live data to the cloud. No SCADA, no expensive middleware, no third-party libraries, just OpenPLC and few lines of Python code with a free IoT dashboard. And in this video, I'm going to show you how you can build that exactly starting from scratch, maybe in just 10 to 12 minutes. This is the OpenPLC series where we explore industrial automation and IoT completely free and open source. So in this video, we will build two examples starting from scratch. One is just showing a temperature value on the PLC logs and then sending this temperature value to the cloud via HTTP and then getting a feedback loop back to the PLC to measure if the value has been sent or not. All right, so let's just get into that. So the first thing is, what is a Python function block and how it is different from IEC? So in standard OpenPLC, you use logic in IEC 61131-3 languages like structured text, ladder logic, function blocks, function block diagram, and these are running inside the PLC, right? Inside the PLC scan time, which are deterministic, fast, real-time, but some tasks which are sometimes much more easier in Python than structured text or ladder logic. For example, HTTP calls, JSON formatting, or working on the strings like statistical calculations or cloud communication. These are much more easier in Python. So in that case, we execute that part of code in Python function block, and then we execute that block to read-write the information. That's why we use Python function block. So here's the key architect. So how the data is being shared. So you have your main PLC logic and you have Python function block, all right? So the main logic works inside the structured text, the IEC language, structured text or ladder or FBD, and then you have a function block which is coded in Python, all right? So this main block will be synchronized based on the PLC scan time, but this Python function block is asynchronous. This blocks run completely separate process, asynchronous. It has its own loop, more or less like 100 milliseconds, all right? So they communicate with each other using shared memory access. All right, the PLC writes the value and the Python reads it directly, and Python processes this, send the value back to PLC. All right, this is how that works. This is done using shared memory. This is working under the hood. You don't have to worry about the shared memory access. You can just read and write to the variable symbolically. All right, so this is how the data is being shared between these two. Now, there are two main functions in the Python. One is block init, and another is block loop. All right, so block init is the function which execute once. So you can use it for steps like initialization, preparing some data structure, initializing the constant values. This is what you can do. But the block loop, it works every 100 milliseconds. It's repeatedly acting. All right, so all the main logic that you want to use in your Python, you should write in the block loop. This is what this is for. So you have to just worry about where to initialize the value and where to execute the main code. Okay, so these are the two main functions, and let's see. So we have several libraries in the Python that you can use right away. So you can see that once you make your Python code, I will show you shortly, it will automatically assign some libraries, but there are more libraries that you can use. I will put a screenshot here that you can have a look. So the next step is, let's build our first code. The goal is to print the temperature value onto the PLC log screen. All right, so let's see how we can do that. In this case, the first step is you need to install OpenPLC editor. I'm going to use OpenPLC editor and OpenPLC runtime, which is installed in my laptop. So I'm not using any hardware. So you can actually implement the same steps that I'm doing right now. If you have a laptop, pause the video, download OpenPLC editor from the website and the runtime, install it, run it, and let's open it now. So I'm going to open OpenPLC editor. This is where I write my code. All right, so in this case, let's create a new project. I'll create a new project. Let's call it Python tutorial 1. Choose the path. I have to define a folder. So in the document, I can create a folder. Open the folder and select the folder. Next. Language, I will use structured text for this case. Let's create a project. So this is the Python editor. So here we are going to write the project. So now, just to make this video not too long, I'm just going to copy paste the code that I already created and tested, and I'm going to explain you what's happening here. So first thing is, we need to create a simulated value. We have to create a temperature value. We have to simulate that. So I just find a very simple way to simulate the values. So I'm just going to copy the code which must be here. So I have to first declare some variables. So here I can declare some variable, which is much more easy to declare. I will write two variables here, which is simulated temp and my angle. So these are the two variables that I declared here. And I'm just going to work on these variables. So angle is basically my angle in radians. So I just have to, I can just copy this code now, and I can show you what is happening here. So this is my piece of code. So what's happening here? So at every scan cycle, so notice that I'm in the main logic, right? This is going to execute. This is a PLC main logic. It's not Python yet. So at every cycle, this angle will increase, and it will go from range from 0 to 6.283. This is my range for radians. And I'm just using this range, using the sine of that, to get the value between -1 to +1. It's just my way to do it. And then you multiply it by 30. So you have a range from -30 to +30. And then you add a constant 50 to it. So now you have a range from 20 to 80. And then I just pass this range to my simulated temp variable here. So that's just my way to generate a sine wave. If you want to see that, I can show you right away. So let's open PLC runtime. So PLC runtime you have to install and just run it, and it will run in the background. And once it's installed, you go to the configuration, or once it's running, select the runtime. I will select runtime version 4. That's the latest one. Put localhost here because it's running in the same machine. And I just wait for it to start. So I was working on that in the last testing, so I hope it's working fine. Looks okay. Now we'll connect on that, put my credentials. It's entered. Let's download using this button. Now it will download this code, and then I can show you in the debug window what you visualize with this piece of code. It's just the simulation values. So seems to work. No errors. Let's debug that. So once you enter the debug mode, you have a possibility to debug your variables. So now you can see that debug is here, and this is my value. If I click on that, you can see it's a very nice simulated value for the temperature. So moving between 20 to 80. Super easy, no fancy things happening here. Now comes the main part. We have to link that with a Python code to display this value. In this case, let's go out of debug mode, go to plus, add a function block. Let's write here example_1, my first example, Python create. Now you have a Python file already created here. Here you have some piece of code, but first let's declare a variable. So in this case, I would like to declare a variable called temp in 1. There you go. That's my first variable. And notice that it has an input class. It's an input variable, temp in 1. Real is a data type. This is an initialize value. Now in the Python code, you can notice that there are some libraries already there. So let me just copy this code where I mentioned some comments, which will help you to understand what's happening here. So now here you can see that we have first library. This will help you by sharing the data between PLC and Python code. That's a library for that. And then you have a struct library. You don't really see the use of this library inside. It's happening behind the hood. It's structure. It's defining the structure of this memory variable. If it's float, if it's integer. And then you have a time library and OS library to help you deal with the time logics. So first you have block initialization. This will only initialize once, like I told you before. So what is happening here? I take a global variable called last print time. Because I'm going to print every 2 seconds, I take two time variables, current time and the last time. So one variable is last print time, and I use it as a global variable. And then I have a last print time, which is assigned the value of current time. This is using time.time function. This is the library, and that's the function. So this will get the current time. And then I just print, using the print command, Python FB started. Very simple. And then you have a block loop. Block loop, remember, runs every 100 milliseconds. All right. In this block loop, I have, again, global declaration of this last print time. And then I have now, this is another variable where I store the current time. Okay, so this is a local variable. Now I compare if now minus last print time is greater than 2 seconds. This is a 2-second timer, simple. Then I will just print. I first move the value of now. I reset my timer because I have to keep on running that. And I will just print it. I will just remove the comment. Print temperature. I just round the value, which I receive here, temp in 1. All right, I will just round it down and show it on the print log. Now you might be wondering, how do I get the value here? Nothing has been passed yet. So this is just the initialization. So I have to go back to my main logic, and I have to call this Python function. In this case, first we will declare. Let's call it my instance _1, and this is my example 1 declaration of this file. All right, and then you can just write here my instance 1, and now we are going to pass the variable to this Python code where we have this variable temp in 1. So we just write here like this. What we're going to pass? Our simulated temperature value and sunny count. This should work now. This is going to pass the value, this function, to this Python, and then we are just printing it in our print log. Super easy, using some time comparison. Let's see if this works. Let's download that in our PLC, and hopefully we should not have any errors. No errors, looks great. And we check the PLC log. There you can see that Python FB started. We already have our first print command, which was coming from here. And then you can see temperature is coming every 2 seconds. You see, super easy is this. You just pass the value to your Python file, execute what you want to do, print it to the log. This was example 1, which was actually super easy. Now we will escalate to the second example, which will make things more interesting. We want to push this value to the cloud. Like I told you, there are some things which you can do very easily using Python. That's why we use Python here in this example. We're going to push the value to ThingsBoard Cloud via HTTP request. All right. How to do that? First thing is you need to make an account on ThingsBoard. It's free, right? You can easily do that. So let's open a browser, and in the browser you can just type thingsboard.cloud, and then you will ask you to sign up. Just sign up. It's for free. I already signed up, so I will just sign in. And then once you sign in, you will be welcome with this screen. Looks very nice. Looks a lot of things are happening here, but just focus on the entities and go to devices and create a new device. I call this device OpenPLC, for example. I label it as well, OpenPLC. Create a device, and now you will have some credentials to communicate with this device. Like I said, I'm going to use HTTP as a mode of communication, and I have this command here. All right. The only thing that I need from here is this URL. So what I do is I just copy this one. Let's put it in a notepad to extract this URL. I paste it here. All right. So this is my URL that I need. Let's do one more thing. Instead of HTTP, let's do HTTPS. Let's have more secure way of connection. So I'm just going to paste it here. So just copy this URL that you need later on. I will keep it like it is. So we have a device which is not active. We are going to send the information to this device via OpenPLC. That's what we're going to do. So come back to our program. And now I will create a new file, function block as well. So let's turn off example 2, this time as well Python create. Now we have a second Python file, and now I just have to put some declaration. So in this case, I take 2 variables. One is input, temp in 2, one is output as a feedback. So very important. 2 variables are here, and I'm just going to copy the code, and I'll explain you what is happening there. All right, so this is the code. Not too complicated, just one extra function for the HTTP. So we have the same libraries that we were working before, and we added 2 more libraries. One is import URL live.request. This library is going to help us to send the HTTP request, like a post request, or put the value to the cloud. And then you have a JSON library because we want to send the payload as JSON string. JSON is a JavaScript object notation, and the value that HTTP required is in string, so we have to dump the value to strings. I'll show you in the code. So first thing is you define the URL that I told you. The URL should be the URL from your device. It's a very unique code. So I'm just going to copy this one from here and paste it here. This will be in the string format, right? So URL is updated. You will have your own URL. And now you have an extra function send to ThingsBoard, and with a bracket payload. And what is a payload? Payload is the value of JSON strings that you want to send to HTTP. Okay. So here we have a function try. So first we try. There's a one variable request, and that is a part of the function from this URL library, URL live.request.request, and then some parameters inside. First is a URL that we define. So this is like a standard parameters. You can't do anything about that. You just have to put the information inside it, right? So URL is the URL of your device, and the data is the payload dot encode. So the payload that we receive later on, I will show you, we send the payload to this function. It will be encoded in this specific format, right? And then you have to add a header to this payload, which is a content type. These are typical string values, application/JSON, right? And once this is defined, you will just use another function, urllib.request.url_open. There you enter this variable and the timeout of 3 seconds. That's it. These are the two things you need to do. And then I'm just printing sent plus payload is what we're gonna throw up. I will show you what it is. And then we just return true. So if this function executed, I get a true as a return value, which is like 1 or 0. 0 is for false. And if it doesn't execute, I will print an error with a string of what is the error. I'm going to print that in my print command. And then I will return false, right? Now comes the block initialization, just like the last one. You have a last sent time. So in the last example, I had last print time, so I'm just using a different name here. We have a global variable last sent time and a status, because we're going to work with the status, like a feedback. So I take two variables here. And then last sent time is equal to my current time plus 5. I use it as an offset because here I'm using time a bit differently. And then initialize the status. The status going back to PLC is 0 initialized. And then I print cloud FB started. This is like initialization. Initialization, what we do is we store the time plus 5, which is like an offset, to the last send time, and status I initialize to 0, and I just print cloud FB started. And now what happened every 100 milliseconds? It's very simple. Again, you initialize global these two variables, which is important because this should be initialized every time when you use inside another function. So if this is like less than 5, it will return. It will do nothing. So as soon as the 5 seconds pass, our function will be executed, which means first the timer will be reset. It's just like which we did in the last example. And then I'll send the payload. This is very important. You send the payload json.dumps. Dumps means it will convert this into a string. That's what payload dumps do. And then what are you sending? You're sending temperature. This is the key, and this is the value. Value is temp into, which is coming over here, and we are just putting it into the float and putting it around, so we just have 2 decimal points. And this is like the payload which HTTP expect in the cloud. That's the way to send the payload. And then you have a variable success, and now what we do is we call this function send to ThingsBoard, and we send this payload which we just created to this function. And now we get a feedback either true or false. And this is what you get here in the success. So I just write, we just convert success into integer. It is 1. Status is another variable here. This is 1 if success is true, otherwise status will be 0, right? Just a feedback. And this 1 and 0 I want to send to the PLC. So let's go back to the PLC now. This is the main code. So we have to now execute second Python function blocks. In this case, I just copy paste this one. I'd make it 2 and put it 2 here. Now instead of 1, I make it 2. Variable was 2, and I'm sending the value. Super easy. What I need to do is I need to now get a feedback. In this case, I make a new variable here. Send status is my integer, and now I read the feedback, which is my instack_2. Sorry, it should be after that. First, it will be here. Send status is equivalent to, this is my instance from here, and the feedback that is coming is status. So intelligently it is showing you already. All right, so this should work, and let's try to save it and download it. Let's see the console for any errors. If not, we should be having the value coming to the cloud and getting a feedback as well. Let's have a look. So everything works fine, successfully compiled. Cloud FB started. This is initialized already. And now in every 5 seconds, we should have a value. There you go. We have a value, temperature 68.16. And now when you open your browser, let's make it short, like this. And you should be able to see the value. So it's inactive. Let's refresh that. This should be active. This is now active. You go inside, check the latest telemetry, and you can see the values coming here, 68.16, 69.33. So you have the value coming live into your cloud. How cool is this? Fraction of minutes, we are able to move the information from our local PLC runtime to the cloud using Python. How cool is that? And now what you can do is you can just if you like, you can create a dashboard. It looks very nice. It takes me 10 seconds. So I'll take a dashboard. I call it OpenPLC. OpenPLC. I create a dashboard, add a widget, go to my temperature widget, and select the device, which is OpenPLC. Temperature is already there. And if I want, I can also, let's make it bigger for a while. So add it. So you can see that the value is coming here, nice and easy. If I want, I can also change this. Here it is, advanced, appearance, widget card, temperature. Apply, and you can close it. There you go. Your value is coming nice and easy on your dashboard from your OpenPLC runtime. Right? You don't have to do anything. Now, if you want to see the, for example, if you want to see the float value, it's not that difficult. You can also do that. You can just check here, appearance, here to apply. There you go. That's it. We have the value now coming directly to our cloud. All right. So if you're doing it with me along this video, you can imagine it's not that difficult, right? So OpenPLC opens up many doors for you because you can do C++ as well. If you have seen my last video, you can do Python as well. You can run your structured text, ladder logic, FBD, anything that you want. A lot of possibility to explore OpenPLC. So there are some key gotchas, right? So I was playing around with this code and I realized there's something I can give you as a tip. So use time.time function. This is very important. If you are working with the time comparison, use this time function instead of loop counter, because loop counter could be unstable in your case. So I recommend you use the time function. Second is declare global variables. So remember that when you're writing the value to the output variables in the Python code, declare it as a global variable. This is recommended. Otherwise, you will not see the value that you expect. And then avoid using special characters in the comments. I had some problems, and then you have compiler issues, and I was not sure what is happening. So make sure your comments does not have special characters. All right. So if you want to learn more, there are more tips on the documentation on Autonomy website. You can. I prefer you to read it before you execute the code, before you get confused what's going on. All right. So most of the time, the question comes when to use Python, when to use structured text, when to use C++. So I would say use Python for cloud communication, JSON formatting, for statistical calculations, for HTTP, MQTT communications, anywhere which will make your code easy because you can use standard libraries, right? And you can use structured text for deterministic control logics, for timing, for sequencing, for interlogs. And if you want to use C++, you can use it to have some raw performance, like direct hardware access. If you have some hardware memory register you want to read and write there, you can use C++ there. It would be easily. And the benefit of using OpenPLC is that you can use all of them in the same projects. If it is Python, C++, structured text, PLC code, you can use all in one project. So this was the video where we explored how we can print a simulated value using a Python on the PLC log, and then we have seen how we can send this value to the cloud via HTTP request and getting a feedback to it. For sure, I think I forgot to show you the feedback. If you want to see the feedback, talking about the feedback, you can see if you go to the main and open the debug, and such an important part I forgot to show you. You can, once the debug is on, you can see the feedback, send status. You can see that the status is 1. So status is coming as a live status. This you can also read it here. All right. So if you find this video useful, please share, like, and comment, and let me know what kind of new content you are looking for, because it genuinely helps me to grow and to make more videos around this topic. And if you want to use the code that I use in the video, I will put this into my Wikipedia. The link is given in the video description, and you can use it as a resource. All right. So thank you, and see you in the next video. Have fun. Bye-bye.